Okay, this is day 3. Let's see what we have in store. Okay, another matrix problem, maximum non-negative product in a matrix. You are given a matrix. Initially, you are located at the top left corner, and in each step, you can only move right or down in the matrix. All possible paths from the corner ending in the bottom corner, m minus 1. Find the path with the maximum non-negative product. So in the whole, maximum non-negative product of all the path is the product of all the integers in the grid cell. So it's like a running sum. From what I can tell, running sum, we have to keep a track of the sum. Grid cell, return the maximum. Okay, could be. Okay, we have an integer modulo, which is equal to how many? 10 to the power of 9. 2, 3, 4, 5, 6, 7, 8, 9, 7, 7. 1 second. How many we should have total? 9 integers. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's correct. And if the maximum product is negative, return minus 1. Okay. So this is here, so to prevent integer overflow. Note that the modulo is performed after getting the maximum product. So what we are given, we can only move right or down. So we have an option either move right or down. So what in the matrix? So and we have to go all the way to our bottom right corner, right? So it could be 1, minus 2, 3, minus 3, 2. So we can never go left. Okay. You are given initially, it could also be a positive in here. So do we take every scenario? So this 15, m is 1 and n is 15. What's m is grid? M is greater than equal to 1. M could be as big as it can, but the number of columns will always be 15. And integers are within 4. Okay, so if we are to start at 0, 0, so what's going to happen is we could from 0, 0, moving right means we are adding, either we go 0, 1 or we go 1 moving right or down. So 1, 0. But so do we take every scenario and among all the possible paths starting from the top left corner ending in the bottom right, all the possible paths? So you're given, we have to return an integer answer. I have an int called answer. I'm gonna assign it. Yeah, maybe we assign it. No. You're given m by n matrix. Initially you are looking at the bottom right corner. Find the math with the maximum non-negative product. So let's let's try. We have the number of rows given, integer m is equal to grid dot len, that's the number of rows, integer n is equal to grid bracket 0 dot, and currently we have initial rows, but we have to start 0, 0 for we can only move product of the path. So running multiple, not sum, running. So do we have an array of all the paths and multiply it? Let's say we find one path, save all the values in that array and multiply, or we could just while finding the path. Okay, let's have an integer. Let me have an array called values. We continue, and since we don't know how many they are, let's have array list values equals to array list. Sorry, I think I have it. It's called integer. So we have a dynamic array to save all the product, and then we find whatever's maximum in here. Okay. So what we want to do, we want to first we have to select a path. So blue for integer, row equals to 0 and column equals to 0. Should we have one loop at a time? And row must be less than. The thing is, we can only go one step at a time. So either we go one row ahead, one column ahead, or one row down. How do we traverse the matrix? Either top or left corner. So 0 to right or the bottom. And how do we traverse? Ending in the bottom right corner, find the path. How do I think about this? How do we traverse right and bottom? Amongst all the possible paths starting from, hey Siri, start a timer. Hey Siri, 1 second. I don't want to spend too much time, like for 10 minutes, try to solve. And among all the possible paths from 0, 0 ending into n minus 1. If we just take the row must be less than, if there's a 3 by 3 matrix. Let me see if I can think about this. So we only can go from 0, 0 to either right side, that would be 0, 1. That's right, and then the bottom down, that would be 1, 0. Do we compare the no, that's 2. So integer r, if we have, should be less than all the rows in r plus plus. Do we do something here before indexing? And the last index, you are given grid. Initially you are located at the top left, that's right here. In each step you can only move right, or to move right or down. Do we need a loop, or can we? So what if we start equals to array 0 comma 0 for, and it's an m by n matrix. So there's 3 by 3, and you step row equals to 0, and for integer column equals to 0, column must be less than n, column plus plus. Do we have an integer called product? Let's do 1. I want to keep it 1 because if I multiply 1 with anything, it'll be the same value. Even if it's multiplied with minus 1, that's fine. And for row and column must be less than 1. So what's happening here is this loop is going right first. This will run for minus 1, minus 2, minus 3. But then it's going to start at minus 2, which I don't want. Among all the possible paths ending in the bottom right corner, find the path with the maximum. Use dynamic, keep the highest value and lowest value you can achieve up to a point. Well, I don't know, I haven't learned dynamic programming as much. Keep the highest value and lowest value you can achieve up to the point. So what is it asking? So do we create a new matrix with the multiple? So if I create a new matrix where each value is the multiple of the previous, or the top, max of top. So let's say if I were to create an array, let's think about it this way. From what I think is create a new matrix, but what does each cell has the max product value we can achieve? But that would be wrong. What if this stuff minus 1, first one starts as is, the second one, for the first loop it will always be the right, that will be 2, this will be 3, but for the bottom, for the middle one, it could either be the top or the, that's so hard. What am I missing? Among all possible paths, starting from corner, dynamic programming is entertaining at the same time. Just try to reach from 0 to bottom, only right and down. This guy says keep 2 variables, max till now, so I don't need to have an array list. Oh, max till now. Oh fuck. You're given matrix grid. Initially you are located at the top right corner, and in each step you can only move right or down in the matrix. Amongst all possible paths, starting from the top left corner and ending in the bottom right corner, find the path with the maximum non-negative product. So keep the highest and lowest value you can achieve. So let's try to follow this instead of that. Let me have high to math dot do I in value to math dot, how do we integer min and high value? I keep forgetting this. Minimum int, is that, I keep forgetting, how do you refer to that? Minimum and max, what's the constant? I forgot. Let's try and ask GPT. I've never, so I'll ask it. Thinking of all possible path and store the product and relist and then x value. It's correct, but it will be too slow. There will be 40 million paths. Okay. Every cell you must track. Current cell value equals to value. Possible previous value will be top cell or the left cell. Yes, that's correct. So you can only go down and right. Keep 2 matrices, max dp. How do we return in the end if? So it's saying instead of all this, so at each cell we keep track of integer. We do have 2 matrices, max dp integer, max dp. So I have 1 equal to new int of m and n integer min. I'm not gonna have ChatGPT solve it for me. I'll try to paste my code and learn, but I'm try to get to the right path by hit and run method. Okay, so we have max and min for each cell, and let me have equals to grid dot length, and integer n equals to grid bracket 0 length. Okay, now I have row and column height and 2 new. Let's see, so far is this correct? It should be. Issue 1, getting matrix in Java grid is an array, not a list. Oh, teacher. Okay, error. Perfect. That's next question. Think before coding. What should be the starting cell value? Cell 0 0 has only one path. So max dp. So for to start with, both the max and min value should be equals to whatever is at the grid. Grid bracket 0 0, and also the min value should also be the same. First row, if you're in the first row, you can only go in from the left. So yes, there is only one path, and if previous cell has, there is only one path. Think if previous cell has 0, current value of grid 0j is should be last in current cell, but current cell values, we're in trouble understanding how to traverse in directions. The dp table like imagine the grid. Yeah, it can only come from the top only. So at oj product keeps multiplying first row code. So okay, we only take less than n. Okay, right now we are only taking the first row for j equals to 1. We don't want to start at 0, 0 because we already have that, and I must be less than m grid dot length. So m or n, we are going to our right number of traversing, right? So shouldn't we go up till n? If matrix is m and m is the number of rows, that's row 1, 2 and 3. What? Yeah, m equals to rows and columns. First travel, so row 0 is fixed, so column changes. So only 0, 1, 0, 2, 3 and 4. Yeah, that's what I was thinking. So why do we have n here then? That's why we loop runs. Okay, for code is this. That's what I was thinking. And g++ integer equals to grid bracket 0 bracket j and max dp max product max dp of at that could be that index is equals to max dp 0 multiply with the previous cell value, that should be j minus 1 times the val, and this v, that should be the min dp as well. Min dp of this, for we have a max and min value, and then this is the first row, and then for I equals to, that's the first row, and first row must be less than m and I plus plus integer value equals to grid bracket 1 comma 0 0 max value for I comma 0 equals to max dp of I minus 1 bracket 0 multiplied by the value, and min product for that would be the same as max dp bracket the top cell value multiplied by the value. Okay, this will populate. So I is 1, 2. So what happens till now? 1 second. So last two loops fill the top row and first column. The base cases after this, every cell can be computed from top and left. Okay, you need to have another, but there are a few errors in your code. I should be, oh yeah, it right here. So what this is the base case for the row, and this is our base case for the column. Now we need to have, okay, now we have to handle all other cells. Should we have nested loop, or okay, for the rest of the grid we should have for teacher I equals to column, because here we started at, instead of I, let's type in row 1, row must be less than m plus plus, and for teacher column should also be equals to 1, because we want to start at plus. So row is less than number of rows, number of columns are here, and now max p at row bracket column, oh sorry, integer equals to grid bracket I bracket j. And now for every cell not in the first, you can come from the top or the left. Yes, so we could have integer max from top to add dot max dp bracket, okay, so max from the top, so we can have the top row, that should be r minus 1, so that's I minus, yeah, minus 1 bracket the column star value, and we need to compare it with the left, whatever is at the left, max dp of, sorry, so we have to compare it max dp from max from the top, min from the top, max and min from the top. Yeah, we need to take only the minimum value that the top shelf, top array has, because min dp of row minus 1 star value, that's correct, because each cell has its own and min. Okay, let's do the same for in max and minimum from top, which should be equals to max dot min of dp from left, oh, max dot min of r1 bracket column should be the exact same thing, star value comma whatever the minimum value is there, because row minus 1 bracket columns, I forgot this, bracket column star value. So we have integer max from the left should be at the max of dp. Now here we want to go to the left, so that's traversing back the column, so of bracket column minus 1 star value, and the min value as the same column, min value of O, and whatever is at column minus 1 multiply the value. Let me just copy paste this part of the code, just copy paste this, and then we have integer min from the left equals to paste the same thing, but instead of max we need the min. Okay, now we have 4 variables, and what do we need? So max dp at that value, row bracket column should be the maximum of left and right that's available. Max from the top, comma max from left, right, from the left, and min dp, and that should be equals to at the minimum. Time is at 2:20 of time. I have to get ready for work. Dot min minimum from the top, minimum from the left. Okay, I have these two. So now we need to choose those one more condition that says return the maximum non-negative modulo. Okay, now so at the last cell, this result is the last cell. The last cell would be m minus 1 and r minus 1. That's correct. So right now, after all these loops, where does this end? This ends right here. Currently last cell has the values, so we will because it's going to be a big, we could have it in long, and then we will divide it with the model result equals to max dp of m minus 1 and n minus 1. Now if it's less than 1, we return. If result is less than 1, is less than 0, return minus 1. If not, then what do we do? So instead of this, we could just use the ternary statement. I think that should work now. Return if result is less than 1, return 1. If not, then we return result. We have to make it into an int. We are casting an int result mod value. Let me write the mod here. Mod equals to 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. This divided by mod. Yeah, GPT, this is a correct way to write. Let's fix this. You don't add f inside a ternary. Alone is enough. Condition. Oh, I don't need to add f. It's less than 0. Return minus 1 and then result mod. Okay, learned something new as well. We are expecting. Also, I want to confirm this because I'm always confused. Do I need to add the underscore, or both of these are correct in Java, especially okay, if you want I can actually have an underscore. Okay, but is an underscore have some ASCII value? Just a syntax. Okay, see you visualize. Okay, find grid ij where? Oh yeah, column and row. And where else? Oh no, row and column. Okay, submit it. Let's see, wrong. What did we do wrong? 20 test cases are failed. Let's me paste it. Maybe somewhere I wrote in. Let's see. There's one small bug in here. Base case. Minimum DP. I0. Where is this? In the first column, base case for column minimum. I0 is equals to I minus 1. Correction, minimum DP I0 is equals. Oh, I have a max here. Min DP. So wrong? Max min. Okay, am I wrong? Max dp min max and okay. Not that. Max and min. Okay. dp equals to the left. So modulus. So do we have a long? Maybe because of integer overflow. I fixed the correction that they said, and then integer. This loop right here. Let me change this to long. I know there's a shortcut to select all these together. Long. Okay. Try. Let me submit it. Compilation. Oh, also be long. Okay. Try and submit this now. Okay. Okay. I'm gonna end the video now. I'll see you guys tomorrow. Okay. Where's my OBS? Sorry. Where is the OBS? Okay.